Okay. All right. So, what are we going to do today? Today is going to be our last class on polynomials. Right. So today is going to be our last class on polynomials, quadratic equations, graphs with polynomials and all. So let's go through it one by one. So first thing first we are going to do is we want to make sure that we go through what happens to the parabola when we deal with the different types of functions, right? That was an assignment for you all. Let's see who all remembers, who all doesn't. And then we will come to the questions that Isha had shared. So we'll just go through them to see are we able to do those problems with the information we have. Okay? Can everybody hear me okay?
Yes.
Oh, okay. All right. So the scenario that we were talking about. So if you look at the WhatsApp message that I had sent across, right? So there are four scenarios. Let's look at one by one. If I have an equation for a parabola which says y equals to fx or fx equals to, let's say, whatever, x squared plus y. Or let's not even go there. Let's say if I have a function for parabola as fx, if I change to f minus x, what happens? If I change, if y is equal to this, if I change it to y equal to function of minus x, what happens? If I say y equals function of this, what happens? If I say y equals to function of x plus or minus, let's say c, a constant, what happens? If I say y equals function of x plus minus c, what happens? So basically two scenarios here, 4, 5 and 6. We're talking about these 6 scenarios. What happens to the parabola? How does the parabola move? Okay, first question. When I have y equals to function of minus x, what happens? Sorry, Baba, you have to be a little louder for me. Across y-axis. Okay, so let's go step by step then. Let's keep it simple. I will keep scenarios as y equals to function of minus x, what happens? Y equals to minus function of x, what happens? Y equals function of x plus minus c, what happens? Y equals function of x plus minus c, what happens? Yeah? So these are 6 scenarios that we are talking about. Let's start with this one first. Let's say your equation is y equals to x squared. That's an easier function, okay? So your parabola will be like this. Okay? So when this is my ordinal function, y equals to function of x, which equals x squared. Okay? So let me do one thing. I will give you guys 5 minutes to go through what I have sent in WhatsApp. Okay? If you scroll a little bit up, there are 2 pictures that I have sent. Okay? That was sent on 14th of July. Okay? These are the 2 pictures that you would have seen. Just go through it and then we will walk through. Just give me 15 seconds, I'll be back. Alright, so let's look at the easy one first. If I have this is my function y equals to x squared. Y equals x squared. If I am adding or subtracting anything from this, what will happen is for every, when x is 0, y still c plus or minus more than 0. Okay? So basically this makes your parabola move up or down by this many points. Okay? So when you are talking about this scenario, when you are adding something outside the function, this, if it is plus, it moves y up because value of y is getting added here. From 0 it moves up or down. So this is a straight scenario. Whenever you have anything getting added outside the function or subtracted outside the function, this makes your parabola move up or down by that many points. The whole parabola shifts by, if you are saying plus, it moves up. If you are saying minus, it moves down. That is these are the two scenarios. Okay? Any question with this one? No? Alright. What does this one say? When my it's moving it along the x-axis. Okay? So this is when my equation function is becoming y equals to x plus minus c, plus or minus c. Okay? What happens is your parabola moves. If it's minus, it moves. It moves in this direction. Okay? Let's look at it one more time. Just want to confirm that I'm not right. So when it's minus, it moves in this direction. When it's plus, it moves in this direction. Meaning, see, let's look at it this way. The way to remember this would be if it's minus, meaning value of y is becoming lesser than this. It's becoming minus. So reduction is moving in this direction, addition is moving in this direction. So it's just opposite of how you would visualize this. Okay? So value of x is, when you are saying plus, meaning value of x is increasing, it moves in this direction. When you are doing a subtraction, it moves in this direction. I mean, we have proved it in the previous class. We can prove it one more time if you guys want to. But just to memorize this, because this is what you will remember for your practice purpose or for page solution. Okay, let's look at one scenario. When y equals to function of x plus c. Okay, let's say, or x plus 2, let's say. So our original function is y equals to x squared. Now what they're doing is, it's saying x minus 2 squared. This is what it will become. So that becomes x squared plus 2x, minus 2x plus 4. So now when x is 0, what is the value of y? Y is 4. So it was here. When x was 0, y was 0. Now what's happening is when x is 0, your y is becoming 4. So this one is when x is 0, y is becoming 4. So it means here. When x is 0, y is 4. When x is equal to 1, what is the value of y? Y becomes 1 minus 2 minus 1 plus 1. So y becomes 3. Okay, x is 0, y is 3. Are you missing something here? Alright, okay, fine. Now we are doing the wrong way. Okay? So here when x is 0, okay, let's take a step back. So first thing simple is when you are adding anything outside the function, that makes it move up or down. If you are adding, it moves up. If you are subtracting, it moves down. Here, in case of when you are doing -2, I mean basically when you are subtracting or adding inside this one. When you are subtracting, it moves in this direction. When you are adding, it moves in the left direction. Now, let's look at this is my, let's say, use the same formula. The vertex is using minus b by 2a. So, okay. So yeah, let's go back to this one, right? So when I have let's go step by step, because if we just solve it for 0, that might make it really confusing. So that's why we have to look at how my lowest point or the vertex is moving into. That's what we look at. So when my equation is y equals to x squared, now we are talking about function of x minus 2 squared. So this is equal to x squared minus 4x plus 4. This was my original function. This has become my new function by subtracting this. So in this case, if my vertex, I am going by the formula minus b by 2a. Okay. So here in this case, minus b is what? 0 by 2a. A is 1. So it becomes 0. Now when I go with this one, the x coordinate for the vertex is minus b. Minus b is minus into minus 4 by 2 into 1. So this becomes 4 by 2. Yeah. This is making clear. Yeah. So the way we have to remember is, if I am doing a subtraction inside the function, it's moving in this direction. Why? Because look at this. When I am doing a subtraction, my equation became like this. When I am putting the value for the vertex, x coordinate the vertex, how is my x coordinate moving? It was originally 0 in case of this. When x is 0, y is 0. In that case, my x coordinate for the vertex is, by putting this value, is minus b by 2a, 0 by 2a. So a is 1, so 0 by 2. That is 0. Now, when I am going for this equation, meaning I am substituting minus 2 here. My equation becomes like this. In that case, what is the x coordinate for my vertex? Is 2. So it moved from 0 to 2. When I am doing a subtraction, it moved in this direction. When I am doing addition, then this minus b by 2a, same thing when you apply, it will become negative. So basically, let's quickly summarize. So I'm creating confusion here, so I'm just trying to solve it and make it simpler. This part is clear. I'm not going to do this one, right? We saw this one. When you add or subtract, it moves up or down. Now we're talking about when I do subtraction or addition inside this one. So my equation is x squared. I'm saying when I make it, instead of x, I'm making x plus or minus c. Then my equation becomes x. I'm just putting a number. Okay? X plus 2 square or x minus 2 square. Okay? When it is plus, my equation becomes y equals to x squared plus 4x plus 4. When I am doing a minus, my equation becomes y equals to x squared minus 4x plus 4. Okay? What we are trying to find out is how is my x coordinate of the vertex moving. This was my parabola here. Now, and the x coordinate, let's say if my x coordinate formula is minus b by 2a. B is the coefficient for x, where we have power of x. A is the coefficient, in the standard form you see, right? A square plus bx plus c. What is my b? B is the coefficient of x, when you have power of 1. A is the coefficient of when you have power of 2. In this case, if I have to look at what is the vertex, x coordinate of the vertex, it is minus b. Here there is no b, there is no x. So minus 0 by 2a. 2 into what is my a here? 1. 2 into 1. So this becomes minus 0 by 2, that is 0. If I look at this equation, what is my x coordinate? Minus b by 2a. Minus b, what is my b? 4. So minus 4 by 2a. What is a? 1. 2 into 1. This is minus 2. When I am looking at this one, what is my x coordinate here? Minus b. Minus b is minus 4 by 2 into a is 1. So this becomes minus into minus plus 4 by 2. That is 2. So look at this. Your x coordinate when you are doing a addition is minus. From 0 it became minus 2. When you are doing a plus it becomes minus. When you are doing a minus it becomes plus. So when you are doing a x minus something, it's becoming plus. So it's moving in this direction. When you are doing a minus, that becomes a plus. So when you are doing minus, it becomes positive. It moves in this direction. When you are doing plus, it becomes negative. It moves in this direction. So confusing, right? Are you guys with me so far?
Yes, sir.
So the summary is, this part is clear, I am not doing that. So you add, it moves up, if you subtract, moves down. Now we are looking at this scenario when I am doing a plus or minus inside this one. When I am doing a plus, my x coordinate for the vertex becomes negative. Meaning when I am doing a plus, it becomes negative. When I am doing minus, it becomes positive. So when I am doing a plus, it becomes negative. Meaning it will move in this direction. When I am doing a minus, it becomes positive. It moves in this direction. So it is just the reverse. So when you have anything inside the function, inside the bracket, if you are doing a plus, it becomes negative, moves this side. If you are doing a minus, it becomes positive, move that side. And what is becoming positive or negative is the x coordinate of the vertex. So we are just picking this point and seeing how it is moving with the plus or minus. When I am doing a plus, it becomes negative, it will move this way. When I am doing minus, it becomes positive, the x coordinate becomes positive. By 2 points, it moves this way. That's it. Yeah. So just remember this, that when you are doing a plus outside the function, it moves up or down. When you are doing plus or minus inside the function, it moves in the opposite direction as you would assume it to. So when you are doing a plus, it will move this side, and on the negative side of the number line. When you are doing a plus, it moves in the, when you are doing plus, it moves in the negative side, meaning on the left hand side. When you are doing a minus, it becomes positive and moves on the right hand side. So it will just be the reverse of how you would assume it. Yeah. So far okay?
Yes, sir.
Okay. Dhanushri? Rutvik?
Yes, sir.
I know I am not giving a very point blank answer. I am just kind of trying to think the way you guys will think while solving it. So that's why, even if I have explained that in the previous classes, I was just trying to make sure that even I remember it the way I would want you guys to remember it, right? So that's why I was solving it. So these 4 scenarios are taken care. They're very simple. When I have plus or minus outside the function, it moves up or down. Positive moves it up, negative moves it down. Similarly, when I am doing a minus or plus, minus moves in the positive direction, meaning on the right hand side. Minus moves in the positive direction. Plus moves in the negative direction. Just the reverse. You are okay? Now, coming to this one. These 4 scenarios are okay, right? Just by looking at the graph, if somebody gives you this is what will come in the exam. Okay? Say you have a parabola like this. Y equals to function of x as x squared plus 3x plus 9. What is the possible answer when this becomes y equals to function x plus 3? Okay. So by looking at this, you will see, okay, fine, this is a plus and this is outside the function. Then we're going to make it move up. So the option that you have there, it is moving up, that is the one you will choose. If you have anything which is coming down, that would not be the answer. So that will be an uptick that you'll have to keep in mind for solving it faster. Okay? Now, similarly, if you have a parabola like this and say, okay, fine, what will be the possible answer for parabola where this function of x minus 2? So in that case, what you see is it's inside the bracket and it's minus 2. Minus 2 meaning it will be the opposite of the way we will think. It is going to, minus is going to move in the positive direction, meaning it will shift to the right. If it says find out which parabola is mapping to x plus 7, this is my equation and this is the parabola given. So as soon as you see a plus 7, that would give you a clue that okay, this is going to make it move in the negative direction. So it is going to be shifted horizontally on the left hand side. Okay? So that would be your interpretation from this one. Yeah? Now comes y equals function of minus x. So what happens in this case? If I have this, or the second scenario is when you have minus function of x. So when you have a minus x inside, what happens? It flips around the y-axis. And how about this one? X-axis, yeah. So it's very simple. The way you will relate it, okay? So when you have a minus outside, meaning the value of y is changing from positive to negative. How it will move from positive to negative? This is your problem. And when you say positive to negative, meaning all the value of y which was positive before has become negative. And the only scenario is when you flip this. Now, whatever you have here, this is getting a mirror against the x-axis. Everything that was positive for y before has become negative. Same value but negative. Yeah? And y equals to function of minus x. How will that be? That means flipping it against the y-axis. So let's say this is a parabola. Y equals as soon as you say go for minus this thing, this makes it flip in this side. See, this is again by the optics. Whatever you have here, now the value of x is becoming negative. Here y, whatever was value of x before, earlier it was y equals to function of x. I'm just telling you guys some dirty tricks to remember this, right? So when here if you see, right, what is the interpretation? My value of y is becoming negative. Whatever was positive, that value of y is becoming negative. So everything will become negative when you flip it this. Or if the parabola was like this, and you go for function of minus x, meaning whatever was negative before, that will be multiplied by negative, meaning that becomes positive. So it will flip and become like this. So basically a minus sign outside the function, that makes your parabola flip upward or downward because the value of y is getting reversed. Whatever was positive becomes negative, whatever was negative becomes positive. So the x-axis is your criteria which will make it interpret that way. Similarly, when you are looking at y equal to function of minus x, in this case, when this is inside the bracket, inside the function. So meaning here, a dirty trick to remember this would be, whatever was my x before is a negative x now. How will your x be negative? If it's here positive, if you bring it here, then only it becomes negative. Every positive x has become negative, or vice versa. So when the negative sign is inside the bracket of the function, it flips against the y-axis. The negative sign is outside the function, that makes it flip against the x-axis. So the 6 scenarios now are when I have, so let's see if you guys remember this now. I'm kind of forcing you guys to memorize this because again explaining it one more time might be time consuming and that would not help us with any purpose, right? So one scenario is y equals to function of x plus minus c. Second scenario, these are two scenarios. Second scenario is y is equals to function of x plus minus c. Third scenario is y equals to minus function x. And fourth scenario is y equals to function of minus x. Now let's see who will remember these 6 scenarios. Y equals to function of minus x. Dhanushri, what will be the scenario? When I am talking about y equal to function of minus x, what would happen to my parabola if I change from y equal to function x to function minus x? Minus function x. What is that? Flip against which one? X axis or y axis? No. It will be x axis. Remember this. The dirty trick I was saying. Every y is becoming a negative y. How would that happen? When you are flipping against the x axis. This was my parabola. Every y is becoming a negative y. Y is positive in this direction. And y is negative in this direction. Every y is becoming a negative y. Then it flips against the x-axis. Okay? Fine? Yeah? Okay, now, so again it's all about how you relate it. Again, you don't have to keep on proving it again and again. Now what we are doing is trying to memorize this in a easier way, in a more optics way, okay? Now, this is my parabola. Y equals to fx. What will happen when I do function of y minus x? Rutvik, any guess? So my function y equals to x squared plus 3. Let's say it's plotting with this one. Okay. Now if I make it function y equals function of minus x, what happens? Rutvik? And it's okay. I mean, it's okay to make mistakes. I'm just helping you guys memorize it. Okay. So I'm not trying to put anybody on the spot. I'm just trying to see how you will memorize it. Yeah, Rutvik, any guesses? I cannot hear you better. Okay, I'll come to Rutvik again. So, Atharv, what will happen?
It's gonna flip across the wire.
Why?
It's negative.
So the stupid trick that I was telling, right? Here, by looking at this, you will say, okay, it's going to flip against the y-axis because whatever was my x before is becoming a negative x. And that is the only scenario that happens when I go to the second quadrant, sorry. Yeah? So this is how you interpret, okay, whatever was my x, now it is becoming negative x. And the only scenario that will happen is when I am flipping against the y-axis. So minus here makes it flip against the x-axis because my y value changes from positive to negative or vice versa. Y minus x inside the bracket makes it flip against the y-axis because whatever was my x before, that has become a negative x. Every x value is negative. Yeah. So I'm just making you guys memorize this by not going through it again and again. So let's go to the next one. So this is my parabola. Now when I do function of x plus c or x plus 3, what will happen, Isha?
It will move up
it will move up by 3 points. So this will go in this direction by 3 points. So every point on this parabola moves up by 3 points. Yeah? Good job. Now, Rutvik, if you can hear me, what will happen if I do a negative x? Sorry, if I do a minus 3? I'm just trying to wake you guys up, okay? Because everybody might be sleepy after a lunch, right? Okay, Rutvik, what will happen if I do a negative?
I think it goes down.
There is no I think, it just goes down. Because don't doubt yourself, okay? Just say it loud and clear, regardless whether it's right or not, okay? If it's not right, I will correct, okay? Don't worry. So it will move down by 3 points. Or whatever point. If I say 7, we move down by 7 points. In this direction by 7 points. So everything shifts below by 7 points. Yeah? The whole parabola shifts. Now, we have 2 more scenarios. We look at this one, we look at this one, and we look at this one. Now let's look at this one. This is my parabola. Y equals whatever, x square plus 5. Now, when I do function x minus 2, what happens, Vaibhav?
So it goes to units right.
I'm sorry?
Goes to units right.
Goes to right by 2 points. Yeah. So simple childish method to remember this. If it's a plus, it goes to the left. Plus becomes minus. Minus becomes plus. Kind of a thing. Okay? So if you are doing a minus 2, that means minus 2 will lead to this moving in the right direction by 2 positive points. So the whole parabola shifts by 2 points. Okay? Minus is making go to the right. So Pranit, there is no brainer. So if it's a plus, it will move to the left. Okay? Alright. So now we have kind of beaten this to death 2-3 times. You guys have a cheat sheet also in the WhatsApp. There are 2 pictures that I have sent on 14th of July. Just take a print out of that. Keep it with you. Just when you look at it 1 or 2 times, you'll remember it. We have kind of discussed about this enough. Okay? Now let's go to the questions that Isha had sent. We'll not try solving it. We'll just take a look at it to see if we have enough information to be able to solve it now. Because there is no new theory that we are going to learn as part of this unit. So, Isha, do you want to read those questions? Let me go to the question again myself. So the first question was on the mod. Point C and D on a number line are both 4 units from point A. Which of the following is the coordinates for C and D? This was a mod function that we had solved, so we are not going there. The next one was, we had a graph which says we had a graph of function y equals to, it was a graph saying graph of y equals to minus of function minus x is shown. For which value of x it is true that function of x will be equal to y. So it says we have a graph given here. Okay? If I go to the graph, it is a graph like this. Okay? It says this is a graph for this function. It says find out for what value of x is true that function of x will be equal to 1. For what value of x? Okay. So it's saying that for what value of x it will be y equals 1 or function of x will be equal to 1. That's what it's saying. Now, here, I'm not going to solve this one, but I'm just telling you the approach. Now you guys know, okay, I have a graph like this. What we have to do is we have to find out what is my function of x. Okay? If I am doing minus of this, what will be my function? What will be the value of y for function of minus x? Let's say. So this is minus. Minus becoming plus. Y's value, if I convert to positive, it will flip against the x-axis. That's the only case when it becomes from positive to negative, right? So if this is my graph, it will flip against the x-axis. Okay? So it will become like this. This will become my function graph to draw. Okay. So here when I'm changing this function to this function, it flips against the x-axis because whatever was negative that has become positive. So this flip. So this is my new graph. Okay. Now it is saying that I have found only this much. I have to find out this much. What will happen when I have to make this as this? Meaning this is what, see, whatever is minus x has to become plus x. Whatever is minus x will have to become plus x or vice versa. So now it will again flip. It flip against the y-axis. Inside the bracket, makes it again flip against the y-axis. Every positive x becomes negative x or vice versa. So this graph is now flipping one more time. So first you flipped it this way, now you are flipping it this way. So this becomes, okay. So from this graph, you have to actually just visualize this graph and see, okay, then, so this was my original graph. This became upside down, okay. Now you have to look at how when I flip it against the y-axis. So then this will become my graph. So when you visualize this graph, you have to look at, this is your new graph. It says for what value of x, y will be 1. So you have to look at where is my y as 1 in this graph and then plot it. This is one way of doing it. Second way of doing it is, you can see the hint in the question also. Anybody has seen this question again? Do you want to tell me how you would go about it? I think you have solved this unit, right? Do you want to tell me how you would want to do it? Okay. So, see, the simpler option is always, you have to visualize this graph. You have to visualize this graph by flipping it based on this understanding. And then you look at which point moves to which place. See, this will be very symmetric graph. I mean, I have not plotted correctly. Now, when you look at the question, look at the graph and you try rotating the graph and see where my y is moving, what will be my corresponding value of it. See, this, if you look at this one, if it, let's say this was my y before. When it flips, it goes here. So what you will see is, when you are flipping it this way, right, your value of x is not changing, only value of y is changing. When you are flipping it this way, then your value of y is not changing, value of x is only changing. So just look at the graph and you will be able to figure out. It's very fairly straightforward. Okay? Just try doing it. Just remember this thing, that when I am changing, see, this is your original function, you have to get to this one. Meaning, first you will take out the minus by flipping it against the x-axis. Okay? And then you are taking the minus out That means you are flipping against the y-axis now. So you are flipping it 2 times and then you can look at the graph and from that you will be able to figure out what the value will be. Okay? You can solve it also, but just by looking at the graph you will be able to solve it. Ishak, have you gotten a chance to look at it one more time or you would want to do it after the class?
I did look at it again.
Okay. So what I would suggest is don't look at, see, if you look at the hint, right, it has answer for it, but that is more complicated. I would want you to do it in a more visual way. Okay, that will be much faster. You don't have to do any calculation actually. You can only remember the six transitions that we talked about, right? It is related to that. One transition is from minus to plus. What happens? My y value is changing, so it moves against the x-axis. Whatever was positive, it has become negative. So it flips against the x-axis. Now, here, if I have to change from here to here, that means my x value is changing. If x value is changed, then I am flipping against the y-axis. So you will flip it once here, and then you will flip it this way. Then you visualize the graph, you will be able to figure out what the answer would be. Okay? Then you can see the points actually. Okay? Yeah? Try doing it after the class and let me know if you are facing an issue. Okay? Yeah?
Yes, sir.
All right. So let's go to the next question now. Next question is, see, the next question is the graph of y equal to function jx and y equals to kx are shown. Which of the following graph is the graph of y equal to j? Okay. So this is an interesting question again, and these are all relatable. I mean, if you remember those 6 conditions, right, from function x to function minus x, function x to minus function x, or plus minus inside the bracket, plus minus outside the bracket. If these 6 conditions you remember, I mean, you are able to easily relate. You will be able to solve it very quickly. It says there are two graphs given here. This is this one. Says this is one graph and this is second graph. This is y equals to kx and this is y equals to jx. So it says which of the following graph is the graph of y of j of k of so which of the following is the graph of j of k of x? So this is my y of k of x. This is my y of j of x. Okay. Says you are given 4 options. Says which of the following is the graph of this. So essentially, if you look at it, the way you will solve is, okay. So this is related to another formula that we have. If you look at the 2 pictures that I was talking about, this is nothing but I forgot to touch on that one. This says okay. So y equals to function x. If I have to find out another y of c of function x, okay, it stretches the graph vertically by a factor c. If this is, let's say this is my graph, whichever, this graph or this graph. it says if you multiply this by a factor here, this stretches the graph by a factor c. Now the question is, what do we mean by stretching of a graph? Yeah. So when it says what, it stretches the graph vertically by c. Now another simple thing. Here when I say stretching by c, meaning every point of y is becoming 3 times wider, 3 times more. Whatever was the value coming for y before, it's getting multiplied by this many times. Meaning, if y was at 2, now it is 2c. Meaning it is moving up. So, everything is moving up by this many this many factors actually. Whatever was 1, that has become, let's say, if c is 3, whatever was 1 has become 3. Whatever was 2, it has become 6. Whatever was 4, it has become. So it is getting dragged in this direction. So your x coordinates are not changing. Your y coordinates are becoming higher. So whatever was the graph was like this, it becomes like this. It becomes like this. For every small increase of x, your corresponding value of y is becoming much more. Okay. So it's like even if it stretches by 2 or 3, it's actually squeezing it or making it higher, go higher actually. Okay. So that's what it means. So here, if you look at when you are doing multiplying this, see this was a function like this. This one was a function. Now j, you are saying that function of this of j, meaning whatever was the value of y before, I am getting now getting multiplied by this. Everything is positive here. So you will see that the whole value of y has become higher. So it will be somewhere, it will become like this. So it has moved up and it would have become more flat, I think. Look at what are the options there. Let's look at the options. I think we will be able to use elimination technique for solving it. So, if you look at this one, the options that we have are okay. So here again, what you have to do is see what you have to do is C decides how much the value of y will increase. Okay. This is your this function y equals to kx. It's saying find out the y of j of kx. J is here. If you look at this one, everything is positive. It starts going negative. Everything is positive. So that means this one is going to get stretched upward. It's going to become bigger actually. So or it's getting multiplied by some positive number. So you will see all the options that you have. You will have to see the one that is moving up, and from here you will see it's moving in the positive direction. So see here it's very high. So here this one will be on the higher side. This is becoming flat. So this will change to this dimension actually. So this side all the numbers are higher and then it becomes flat. So this one will also move up because getting multiplied by some fraction here. So it will move up and it will follow the same shape actually. Yeah. So look at all the options. Try solving it with this understanding that okay, if you are multiplying a function by a constant outside, it drags your graph vertically, or your value of y becomes more more steep actually. Yeah. Try doing it that way and tell me. And here for these questions, right, there is no no mathematical solution, I would say. I mean, don't go for mathematical option because you'll end up spending a lot of time solving it. It will be more of a, the visual thing that you have to look at. The option that I have, okay, by looking at this, you will find, okay, this graph is all positive. In the first and second quadrant. So my value of y is positive here. Here what I am doing is, so function of this graph is applying on this one. So whatever I have here, that is getting multiplied with positive things, so it has to move up. Anything which is in the third or fourth quadrant, that might not be of interest for you guys. You have to look at what is in the first and second quadrant, and before is aligning with this relationship that you see here. Okay? Am I making sense here, or you guys are kind of getting more confused with what I'm saying? Making sense? Isha, Dhanushri,
Yes, sir.
making sense? Athar?
I didn't get the part where it's turned over at the third and fourth quadrant.
So it turns over third and fourth quadrant. So see, the underlying concept is this one. Okay. So on the 14th July, there were two pictures that I had put, right, which had all the rules that we have kind of gone through today. There was one rule that was missing there, was saying that, okay, if I have a function like this, and if I multiply this function with a constant like this. So far we have seen what will happen if I add or subtract inside this one, or if I make from here to minus x, or if I make minus x here. Here this one was when you are multiplying a function with a constant. So when you are multiplying the function with a constant, what it does is, your value of y is being multiplied by this. So if your value of y was 2, for the same graph, the value of y will be 2 times more than what it was before for every point. So your value of y is becoming more steep. So what this rule says is, when you are multiplying a function with a constant outside, your graph gets stretched vertically by this thing. So this was your, let's say this was your graph. I don't know how I'm plotting this. Okay, let's say this was your graph. Now every y, let's say which was 2 here, has become 2 into 3, 6. So it has gone up. Your whole graph is moving up. It's getting stretched. If you multiply by 20, it will become more steep. So which was here, that has become like this. So it's getting vertically stretched. That's what it's saying. So here in this case, what I was saying was, the question was that this is your one graph saying y equal to j of x. And this is your second graph which is which is y equal to k of x. Now it's saying find out which is the right graph for j of k of x. Meaning whatever value you get from k of x, which is this graph, you are adding j to it. So here, if you look at this graph, everything is positive here. Whatever value of y you are getting is all positive, nothing is negative. That means when you are multiplying that fraction, whatever value of y you are getting from here, inside this one, because we are saying j of this value. So whatever is the value, you are multiplying that value and then using this function. Meaning it will be a function which is getting multiplied by a positive number, and this is getting stretched and getting moved up because everything is positive here. So it will not remain the third or fourth quadrant because that is where you have value of y is negative. Here your value of y is getting multiplied by a positive number. So everything is getting moved up and getting stretched this way. So visually, what I was trying to say was, when you look at this kind of a graph, you don't have to get to the calculation part of it. You look at the interpretation. Okay, my thing says, okay, if I'm multiplying by a constant, which is a positive constant, my graph is getting vertically stretched. Here in this graph, this is getting substituted inside this function, and this function is everything positive. So whatever value I'm getting here, I'm putting in this function, and you're getting in positive numbers, or I'm getting it stretched vertically. So if I have 4 options to choose from, if I'm seeing any option which is in third and fourth quadrant, I'll probably not lean on that because I'm seeing everything getting stretched, becoming bigger, positive, and something which is above this x-axis kind of a thing. Yeah? So it was more of an interpretation that you have to look at. and then obviously once you get the answers, try matching that answer with what is there in the summary, and you'll be able to relate. There might be a different way of interpreting it, but I'm probably telling you, I would not claim that's a more practical way, but something that you can relate visually rather than doing it in a more complex way. I see Aditi also has joined. So Aditi, you are early by a few minutes. Let me finish this class, then we'll start your class, okay?
Yes, sir.
Alright, so everybody clear with this one? Okay. So these are all more on interpretation side of things. Then we have another one on, okay, this one is exponential graph of y equals g mass x passes through line this. If g is an exponential function, which of the following could define g? Okay, so this is just a equation that you have to substitute value and you should be able to solve it. I'm not going into that one. I think we have solved this one before. And there is one more question on the graph which says, for a function of g, the graph of y equals to gx is shown when gx is divided by x plus 10. The remainder is minus 2. Which of the following closest to? Okay. So here, I think same thing. The 6 formulas or 7 formulas are there now. The 7 formulas that we have learned about how the shifting of graph happens, how the parabola moves, you should be able to relate to those 7 rules and should be able to solve this. Now this is the assignment. Let's try doing the unit test for entire unit 12. Okay. If you guys have done it, wonderful. If not, please do it. I want you guys to do this unit test by yourself, apply these rules, try doing it, and see where you are getting stuck. Okay? That will be the assignment for this week. I would want you guys to do it. Use the interpretation that we have, use the rules that we have learned so far, apply them, try doing that in a more intuitive way, in a more optical way than trying to solve it. Because in this one, most of the questions that you will have will be based on how you interpret different graphs, how you relate them with the rules and apply them. Okay? Solving the equation will be more part of when you are dealing with quadratic equations or solving for x and y, right? But not for the graph function. It will be more on the intuitive part of it. If you are able to relate it, they should be able to solve it. Okay? Let's do the unit test and let me know if you guys are struggling anywhere. From tomorrow we will start a fresh unit and move away from unit 12. We have done enough of unit 12 so far. Isha, if you have any consideration to be made for any other unit, let me know. You will be given priority among other kids, at least for the month of July and August. Okay? After August, then we'll go in a flow. Alright? So Isha, you check and let me know which one you would want to start with from tomorrow. Which unit rather, okay? Or which topic if you have any preference among the topics. And then we will, once we finish the recommendations from Isha, then we will start with the normal flow, start from beginning and then see how soon we can do one round of all the units, do the test. And then another message for you all is, we will start doing the test every month now. Okay? That is when I would want you guys to come over to the classroom. Except for some of you who are living very far, like Rutvik. But we will do once in a class test to see whatever we have learned, how much we are able to get, where we are getting stuck. And then we learn some more topic and then do test one more time next month and see how much has improved, right? So that way it will be like a rehearsal for a city test. And I will try getting some pre-SAT question papers. We'll just use that regardless of whether we have covered those topics or not. We'll just do some tests and see what we know versus what we don't, and then we'll be able to reassess ourselves and focus on the area that needs focus. Okay? Alright?